maybe read the problem first.
Yeah. So in preparing a cold drink with a final temperature of 0 degrees Celsius, Mary mixes 50 grams of ice at negative 10 degrees Celsius with some juice at positive 10 degrees Celsius. The heat capacity of juice is 4,000 joules per K times, so yeah, kilograms times degrees Celsius.
All right.
Yeah.
I lost already. So she's making juice.
Yeah, she's making a drink with 50 grams of ice at negative 10 degrees, and some amount of juice at positive 10 degrees, and she wants the final temperature to be 0 degrees. So then the question that I'm stuck on is, what is the mass of juice that she should add so that all of the ice is just melted?
Okay. First of all, can you see the screen? Is it blurry?
It's kind of blurry. Yeah.
If it's blurry, you have to tell me every time because is it better?
There it is. Yeah. Yes.
Okay. If it becomes blurry again, tell me. I can focus.
Okay.
So you are absolutely right that in this situation, because the final temperature is 0, we actually can have several options. For example, the option number 1.
No, it's blurry.
No ice left. Yeah, everything is liquid. The option number 2. No water left. Everything is solid.
Mm-hmm.
And technically, the option number 3 is a mixture. And they all may have final temperature of 0, because that's what, phase transition temperature is equal to.
Right.
So, in your case, there should be no ice left, yes?
Mm-hmm. Right.
All right. So.
Oh, your screen went blurry again.
Okay, I'm gonna just share it in that case. How do I do that? So I'm gonna do this. No. Just a second. Sharing. Share. All right, and something like that. Okay. All right, now you should see it, right?
Yes. Yes.
And how many processes do you consider for this situation?
So there would be the cooling of the juice, there would be the warming of the ice, and then there would be the melting of the ice. So there would be 3.
Absolutely right. That could have been the only reason for actually making a mistake. So the process number 1 requires a certain amount of heat, Cm delta T1, well, C1 and 1.
Mm-hmm.
Then the process number 2, melting.
Mm-hmm.
And this is the process number 3, cooling water, C2, M2 delta T2. And this is all probably in a kind of thermal insulating cup.
Right.
So Q1 plus Q2 plus Q3 is supposed to be equal to 0. And you should use the values given in that practice exam. Probably for ice, it's probably 2000, right?
Yes.
And you use SI, International System of Units, so
right.
Let's assume automatically for water, that's probably 4,000, yeah?
Right.
And for the latent heat?
It's 3 times 10 to the 5th joules per kilogram. Yeah.
Yeah, that's what usually is standard. Okay, so let's just plug the numbers in.
Mm-hmm.
Q1, 2,000 times, how much ice did you have? Did she have?
It says 50 grams.
50.
Yes.
Because everything is equal to 0, we can use grams. We can use any units, actually.
Okay.
So times 50 times final minus initial.
Oh, okay. Yeah. Okay.
Well, I'm just writing down step by step, yeah? Final,
Yeah,
final
no,
is supposed to be
I-
0, and the initial for the ice was -10, correct?
Yeah, your first parenthesis looked like a 1
Oh,
instead of a
okay,
parenthesis,
sorry.
so I was, yeah.
Yeah,
You're good.
I know. I've got many issues with writing.
It's okay,
All right.
me too.
Next step. This kind of a tricky part because you have to choose a plus or a minus.
Mhm.
What did you choose?
I had a plus.
Yes, because you have to melt it. So ice
Right.
should absorb this amount of heat
Mhm.
times same mass. And now plus 4,000 times the unknown mass. That's what you're looking for, right?
Mhm.
And final temperature is 0, and initial was 10, and that has to be equal to 0. I'm gonna do it here.
Okay.
This is the equation, and if you solve it, you should get grams,
Okay.
because I'm using grams here and grams there.
Let's see.
Now what I am doing is crossing out zeros. So how many zeros can I cross out? I can, well, maybe write one more time. So it's gonna be, I can multiply it in my head. 2 times 5 is 10.
Yeah.
1, 2, 3. One more. One more. Okay.
Mhm.
Plus 3 times 5, 15. 1, 2, 3, 4, 5, 6. Has to be equal to, if I bring it over there, m2 times 4. 1, 2, 3, 4. Now please check my mathematics.
That should be right. Yeah.
I think that's correct. Okay.
Yeah.
Now 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. So what I've got here, 1, 5, 1. No, 1600 equals 4 times m2. M2 should be equal to 400 grams.
Okay. Yeah, that's what I got, and the key said 62.5.
Well, I bet that would have been if you have no water left.
Oh.
Maybe there are maybe answers are mismatched with questions.
Right. Okay.
Because if you would have to finish this, well, if you would have to solve the same problem, but with no water left, you would have a different set of processes.
Mhm.
So you got what? You got
The ice.
ice
cools.
that should warm up, and you have water that should cool down, and it should freeze.
Yes.
So in order to do that, you should really have a really small amount of water.
Yeah.
That would be
It was like-
Q1, Q2 would be negative ml, Q3, and if you do calculation, I bet that would give you 62 grams.
Okay.
So no water left.
Let's see.
So your equation would have been practically the same with a minus, right? Instead of a
Yeah. Yeah. Let's see.
plus. Another thing, you wouldn't use 50 here. You would have to use M2, the mass of water.
Mhm.
So
I could solve for that on my own time and see if
I just
that-
want to see if the equation actually is correct. So that should be this times this minus -10 plus, technically we're adding, what do we add? Amount of heat, water, M2 should lose
Mhm.
plus 4,000, same amount of water, and 0 minus 10 equals 0. So I'm pretty sure if you do it right, that, well, hopefully the exam has correct answer.
Yeah. Let's see. My math is slow.
So no ice left versus, this is part number 1, versus Part number 2, no water left.
Okay. Let's see.
10. 1, 2, 3, 4, 5 should be equal to M2, 3, 1, 2, 3, 4, 5 plus 4, 1, 2, 3, 4. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. 100 over 34.
Yeah, and that's the correct answer because the key said 2.9 grams, or it was like 50 over 17. Yeah. Okay.
2.94.
All right. Okay. So for the first one, if we both got 400 grams, then I think.
Yeah, I wasn't checking those exams for a long time. Which exam is this?
This is exam 3, so I don't know how long ago that was that you gave that one.
It could have been not me, actually.
Or yeah.
Because those are collections. All
Okay.
right. When I have time, I will check. And this is the problem number.
Problem. It's just oh, that's weird. Yeah, 4th page. Problem C. They're not actually numbered.
Okay.
It's okay though. Okay.
Okay.
All right. I think that clears things up. Thank you for your time.
Of course.
All right. Take care.
You too. Have a nice day.
You too.
All right. Anyone else? Anybody else? No, only one participant. So we can stop doing this and we can stop doing this.